Algebra II, 4.8b, Linear Programming and Theorem. This is a continuation of 4.8a. If you haven't seen the previous videos, you can click on the description of this video and watch those very quickly, okay? I don't want you to get confused. So here's our theorem. It's to solve linear programming. Suppose a quantity f is given by a linear equation, f equals ax plus by plus c, and that the set of ordered pairs x and y, for which the equation makes sense, can be described by a system of linear inequalities. If the graph of this system consists of a polygon and its interior, then f has a maximum and a minimum value that occur at the vertices. Now, what this means is, in plain English, if we have a linear equation of that form, that one right here, f equals ax plus by plus c, and we solve it for x and y, the graph we make will have a polygon whose vertices will give us the maximum and minimum values. That's all. If you saw the last video, you completely understand. So here's our first problem. Bob's factory makes mopeds and bicycles. He learned from experience that he must make at least 10 mopeds to stay in business each month. His factory can make 60 mopeds and 120 bicycles at most each month. The profit of one moped is $134 and $20 for one bicycle. They can make at most 160 units combined. So they can't make any more than that. Their factory isn't equipped to, okay? So how many of each should he make each month to maximize his profit so his company can make the most money? How many mopeds, how many bicycles? What's the combination? So we're going to let x equal the number of mopeds to make, and y is going to be the number of bicycles he needs to make. The profit is going to be 134x plus 20y, and it's going to be subject to some constraints. Now, we got the 134x from how much he profits from one moped, and x is a moped, that's the profit, and the 20y is the profit for one bicycle, and bicycle is y. So here's the constraints, that it's got to be greater than or equal to 10 mopeds to stay in business each month, and he can't make more than 60. That's the most he can make. So x, the mopeds, has to be greater than or equal to 10 or less than or equal to 60. For the bicycles, he can make a 0 if he wants to, but he can't make more than 120. So y is greater than or equal to 0 and less than or equal to 120. The x and the y, the mopeds and the bicycles, are less than or equal to 160, because that's the total he can make. It says he can't make more than 160 units combined, right? So now we have a system of three inequalities, and we can solve, graph, find the vertices, and solve our equations for the maximum profit he can make. So we're going to take these three and this as p equals, all right? And that's our system of inequalities. So now we've got profit equals 134x plus 20y, and we've got our three inequalities in our system. These are our constraints, okay? We talked about that before. Those are our limits, all right? We've got 10, that one right here. We've got the one with the 0 right here, and we've got the x plus y one right here. See that? So because x is greater than or equal to 10 and less than or equal to 60, we set them with an equal sign. X equals 10, x equals 60. And for this one, we set it as y equals 0, y equals 120. See, because the y is in the center, it's either or. And we've got x plus y equals 160. All right? So now we can start graphing them. Well, if x is a 10, then there's no y value. X is just going to be 10. So on my plane here, on my coordinate grid here, I've got each square is set by 10, 10, 20, 30, 40, 50, see? And for this one, here's 10, here's 50, here's 100, here's 150. So if x is 10, we're going to color this line red, because I gave that one a red color, okay, so we can identify it. So here's x is 10, and here's x is 60. So those are our constraints for our limits, our boundaries for our polygon, okay? So now we've got the boundaries on each side. For the green one here, y is equal to 0, and also y is equal to 120. So y being a 0 is this line right here at 0. It's the x-axis, isn't it? Because that's where y is 0. So that's the bottom constraint, the bottom boundary line, and then y is 120 is going to be the top one. So we draw y is 120 here. Now it says x plus y is 160. Well, if x is 160, that's right here, 10 after 150 at this point. And if y is 160, then that's right here, and we connect these lines here, okay? Because x and y is 160. So at 160 and 160 on the y and the x, we draw our blue line. Now we can see our feasible region. Remember, the inside of the polygon is called the feasible region? We can write our vertices. We've got this one down here at 10, 0. We've got 10, 120. We've got 40, 120. We got 60, 100, and 60, 0. We write our vertices over here. See? These are all the ones that are the vertices, the x and y values, and we plug it into our profit equation. So this is the x, this is the y, 134 times 10 plus 20 times 0 would be $1,340. 134 times 10 plus 20 times 120 would be 3,740. 134 times 40 plus 20 times 120 is 7,760. 134 times 60 plus 20 times 100 is $10,040. Well, that's our maximum profit right there. That's the largest amount. And then we have 134 times 60 and 20 times 0, which got us to 8,040. So this tells us right here, if x is mopeds and y is bicycles, if Bob's factory makes 60 mopeds and 100 bicycles, see, his company will make the highest profit. All right? So here's what we did. All right, I'll step back just a little bit. We assigned the variables. Then we wrote an equation for the total or the profit, the 134x plus 20. We wrote our constraints that were binding us to a certain limit. We set our inequalities to an equal sign. See? We graphed the x and y pairs. We graphed these on here. We found the vertices, and we listed them. And then we substituted x and y vertex values into the equation here to find out the maximum profit, the total. See? So after the last couple of videos, you should really have this by now, okay? Just remember that after you find the vertices, plug it into the equation, okay? Don't forget, you're not done once you're here. You have to continue on, plug it into the equation, use the x and y values to multiply or add, and find your maximum or minimum that you're supposed to find, okay? All right, that's linear programming. And our next video is 5.1a, and we're going to talk about polynomial functions and the degree of a term. So I'm going to add this video to the Algebra II playlist. You can use it for studying or whatever you need. And I'm going to have a link to the Algebra I videos from Chapter 5, that playlist on exponents and polynomials, if you need to go reflect back to last year to remember, because I know it was a long time ago. Last year was a while ago, and you haven't seen this for a while, so it wouldn't hurt to bone up and practice and look at stuff you did last year real quick, watch a couple videos and say, oh, I remember that. It might make this year easier, all right? Good luck, keep up the good work, and I'll see you next video. Bye.